So now we're going to take up one more example wherein a regular pentagonal lamina of 25 mm side is resting on one of its corners on HP, while the side opposite to this touches VP. If the lamina makes an angle of 60 degree with HP and 30 degree with PP, draw the projections of the lamina. So this is the problem. So first condition what he says is a regular pentagonal lamina of 25 mm side is resting on one of its corners on HP. So since it is resting on HP, so we have to start the problem from HP. Now since it is a pentagon wherein you have the odd number of sides, that means you have 5 sides. So wherein you will going to get make this side perpendicular to VP and construct this pentagon, and here opposite to this side will going to be the corner. So here all the corner points are resting on HP. So and this is a case wherein the surface is parallel to HP and perpendicular to VP. And when you see here in the two-dimensional sketch, here this is the edge. When you look from the top view, the edge is perpendicular to VP and this is the corner. Always remember the corner will going to have a single point, whereas the edge will going to have the 2 points. Next, so here construct this pentagon by drawing at an angle the construction by drawing at an included angle of 108 degree and construct the pentagon, and then project this to the XY line and to get this particular line. So this is here, since it is perpendicular to VP, so in VP you are getting a line. So that is what in VP you are getting a line. In the next position, he says that it is resting on one of its corners on HP. In this case, all the corners are resting on HP and he wants only one of the corners, which is the corner which has to be rested on HP, the extreme point of that particular line. So which is the extreme point of that particular line? One is A dash and the other one is C dash D dash. But since C dash D dash is an edge, whereas the corner is A dash, so since it is resting on one of its corners, so you make that A dash on XY line. So that is the reason why the A dash is on XY line, that is the intersection of VP and HP will move to be the XY line. And the lamina makes an angle of 60 degree with HP. So this is the lamina, means it is the surface of the lamina is inclined at 60 degrees with HP. So you rotate this by an angle of 60 degrees. So that means the surface makes an angle of 60 degree with HP. So this is what we have given here, which is a pentagon where the surface is inclined at 60 degrees to HP with corner on HP. So here construct any point, take any point on the XY line and draw a 60 degree line and measure the distance from A dash to C dash with A dash as center, cut an arc on this. Similarly, measure the distance from A dash to B dash with A dash, cut an arc on this by using the compass. Then rewrite this, then project these points to the top view, and from A dash you draw a vertical projector and from A you draw the horizontal projector to get this point. Similarly, B dash to B, and similarly C dash to C, D to D and E to E. So once you construct this, so the lamina makes an angle of 60 degrees with HP. Now we will go to the next position. While the side opposite to this touches VP. So which is the side opposite to this? The side opposite to the corner. Which is the side opposite to the corner? The corner is this. Which is the side opposite? Which is the side opposite to the corner? The side opposite to the corner is CD. The CD touches VP. Now the CD touches VP here. In case you can see here, the CD which is perpendicular to VP is touching VP. And reconstruct this pentagon by constructing this. How? You measure the length from C to D. You take any point on XY line and mark that point. And you measure the length from C to this perpendicular line, and from C you mark this point. And draw a perpendicular from this point by using a protractor, and then measure the length from here to here, and from this point you cut it. Similarly, you measure the length from this point to this point, and from this point you cut it, and through this point you draw a perpendicular. So it is already there, it is a perpendicular here. So once you get this point, through this point you draw a perpendicular to this and measure the length from this point to B, and from that point you cut an arc on this. Similarly, measure the point from this to this, and from this point you cut this. So you join the pentagon. Once you get the pentagon and you project this to get the front view. Through A you draw a vertical projector, through A dash you draw a horizontal projector to get this point. Similarly, draw a vertical projector from B and draw a horizontal projection from B dash to get this point. Draw a vertical projector from C and draw a horizontal projector from C dash. Similarly, draw a vertical projector from D to get this point, from E to get this point, E dash. So join the pentagon. So this is also a surface and this is also a surface. So this is a case wherein the surface is inclined to both HP and VP. Obviously that surface will going to be perpendicular to the profile plane. So we know that from the third position of the introduction of lamina, when the surface is inclined at both the both the planes, then obviously that surface will going to be perpendicular to the profile plane. Only in the profile plane we can see the inclination with respect to both HP and VP. So here, if the lamina makes an angle of 60 degrees with HP, so that lamina of 60 degrees with HP is already here, but we are not able to find out the 30 degrees with VP here. This is because the surface is also inclined to VP here. So here, since the surface is inclined to VP and also inclined to HP, so obviously now the surface will be perpendicular to VP. So you draw a 45 degree line here and project the point A to this 45 degree line, and from here you draw a vertical project to get to this point because A dash is here, so A double dash will be here. Similarly, from B you draw this to get the point A double dash and B double dash, and similarly from C you draw to the origin, and from here you project this to get C dash, C double dash and D double dash. So in order to view this, you view from here. D double dash is near to the observer, it is visible. C double dash is away from the observer, it is invisible. E double dash is near to the observer, it is visible. B double dash is away from the observer, it is invisible. A double dash is visible. So here the 30 degree with VP can be seen in the profile view. You can see here the 30 degree with profile view, that 30 degree is here, which is also inclined to VP. Similarly, 60 degrees to HP, it is inclined at 60 degrees to HP. So that is how we will be able to solve this particular problem of the lamina, pentagonal lamina, which is inclined to both HP and VP. Whether the problem is right or wrong, how we are going to come to know? Here, the corner is resting on HP, the side opposite to the corner touches VP. Here also you can see corner is resting on HP, the side opposite to the corner touches VP. And the surface makes an angle of 60 degree with HP, and the surface makes an angle of 60 degrees with HP here. That surface is also inclined to HP. So this is HP and this is VP in the profile view, 60 degrees to HP and 30 degrees to VP, and the corner is resting on HP, and this is a regular pentagon of 25 mm sides. So this is how we will be able to solve this particular problem.